Welcome. Today we're diving into the heart of electrical power, right here in your university lab. This is where theory meets practice, and where you get to see the magic of electricity unfold before your eyes. This demo substation isn't just wires and switches, it's your hands-on gateway to understanding how electricity travels from power plants to your devices. You'll get to manipulate the components and see how each part plays a crucial role in the bigger picture. Here, you'll move beyond theory, operating real equipment and seeing the results instantly. It's an opportunity to bridge the gap between what you learn in textbooks and how it applies in the real world. This lab is your training ground, safe, controlled, and designed for you to experiment, learn, and build confidence. Safety is paramount, and you'll be guided every step of the way to ensure you understand the importance of each procedure. You'll master the basics of voltage transformation, circuit protection, and the intricacies of how these systems work together to deliver power efficiently and safely. And troubleshooting, skills that power real cities. These are the foundational skills that will prepare you for a career in electrical engineering, making you a vital part of the energy sector. Let's approach this with curiosity and respect. This is your first step into the world of electrical engineering. Embrace the learning process and take full advantage of the resources available to you. Ready to flip some switches and unlock the secrets of the grid? Let's get started. Your journey into the fascinating world of electrical power begins now. Before powering up, let's meet the main components of your demo substation. The power supply is your starting point, feeding electricity into the system. Isolator switches act as gatekeepers, safely disconnecting parts of the circuit for maintenance. The transformer steps voltage down to safer, usable levels. Circuit breakers protect the system, instantly cutting power during faults. Meters, voltmeters, ammeters, wattmeters give you real-time data on system health. Busbars distribute power efficiently, while protective relays detect faults and trigger breakers. Understanding these players is your first step to confidently operating the substation. Safety first, always. Before you even think about starting any work in the electrical substation lab, remember that your well-being is the top priority. Every step you take should be guided by caution and awareness. Before touching anything, put on your PPE, safety glasses, insulated gloves, and closed-toe shoes. These are your first line of defense against electrical hazards and accidental contact. Take a moment to carefully inspect the substation for loose wires, frayed cables, or stray metal objects that could pose a risk. Even small issues can lead to big problems if overlooked. Ensure the area is clean and dry, with no puddles, clutter, or debris that could cause slips or electrical shorts. A tidy workspace is a safer workspace. Know exactly where the emergency shutoff button is located. In an emergency, seconds count, so make sure you and your team can reach it quickly. Confirm all switches, isolators, and breakers are off. This is your safe starting point. Never assume, always check for yourself. Visually check for open gaps in isolators, making sure there's no chance of accidental connection or current flow. Double-check the off positions on all breakers, confirming that every switch is exactly where it should be before proceeding. Always work with a partner or under supervision. Double-check each step together. Teamwork helps catch mistakes and keeps everyone accountable. Discuss your plan before starting. Clarity prevents mistakes. Make sure everyone understands their role and the sequence of steps. In electrical labs, check, double-check, and stay alert. Your safety depends on it. A thorough pre-flight checklist is the foundation of every safe and successful lab session. Time to power up. This is the moment where all your careful preparation comes together. The substation, which has been silent and still, is about to come alive with energy. Every step you take from here is crucial for a safe and successful startup. With all safety checks complete, it's time to turn on the main power supply. Watch for the indicator light. It's your first sign that electricity is flowing into the system. This small glow means your substation is ready for the next steps. Next, close the isolator switches on both the primary and secondary sides. These switches create a complete circuit path, allowing power to move safely through the transformer. Double-check that each switch is fully engaged before moving on. Now, engage the circuit breaker to energize the transformer. You'll hear a solid clunk as the mechanism locks into place. This sound signals that the transformer is now live and ready to step voltage up or down as needed. Check your meters carefully. The primary voltmeter should display the input voltage, while the secondary meter will show a lower output, confirming the transformer is working. Take a moment to compare the readings and ensure they match your expected values. Now, connect your load, such as a bank of bulbs or another test device. Make sure the load switch is off before attaching it to the terminals. This step prevents sudden surges and keeps your setup safe. Flip the load switch on. Instantly, the bulbs should light up, and the ammeters will show current flowing through the circuit. This is a clear sign that your substation is distributing power just as it would in the real world. You've just simulated real-world power distribution, safely and successfully. The energized equipment and glowing indicators show that your system is functioning as designed. Keep monitoring your instruments throughout the process. Watch for any unusual readings or warning indicators. This is how you develop the skills to spot issues early and maintain a safe, reliable substation. Congratulations! You've brought your lab substation to life, mastering each step with attention and care. This hands-on experience is the foundation for real-world electrical engineering success. Shutting down is as crucial as powering up. First, turn off the load, watch the ammeter drop to 0, trip the main circuit breaker to de-energize the transformer. Voltmeters should read 0. Open the isolator switches starting with the primary, then the secondary, creating a visible air gap. Turn off the main power supply, the indicator light goes out. Leave the substation with isolators open. This signals it's safely off. Tidy up, complete your report, and practice this shutdown until it's second nature.
Have you ever wondered how electricity gets from a giant power plant all the way to your house so you can charge your tablet or turn on the lights? It's a huge journey, and one of the most important stops along the way is a place called a substation. You might have seen one before. They are usually fenced-off areas with lots of big metal structures, wires, and machines that hum and buzz. These substations are like the busy traffic control centers for electricity. They are a super important part of the electrical grid, which is the giant network that connects power plants to all of our homes, schools, and businesses. Without substations, the power couldn't get where it needs to go. Think of electricity traveling on a highway. When it leaves the power plant, it's moving at a very high speed, or what we call high voltage. This high voltage is great for traveling long distances, just like a car goes fast on a freeway. But you can't drive at freeway speeds on your own street. Before that electricity can safely enter your home, its voltage needs to be lowered to a much safer level. This is the main job of a substation. It acts like an off-ramp and a traffic light, taking the high-voltage electricity and changing it to a lower voltage that is safe for our neighborhoods and all the things we plug into the wall. It's a critical step in the process. Substations do more than just change the voltage. They are also like the brain of the local power grid, constantly monitoring and directing the flow of electricity. They can switch power from one path to another, a bit like a train dispatcher changing tracks. This is really useful if there's a problem like a storm that knocks down a power line. The substation can reroute the electricity around the damaged area to keep the power on for as many people as possible. They are filled with special equipment designed to protect the grid and ensure that the flow of power is steady and reliable for everyone who depends on it every single day. So the next time you see one of those fenced-in areas with all the impressive-looking equipment, you'll know what it is. It's not just a collection of metal and wires, it's a hard-working substation. It's a vital link in the chain that brings electricity to us, making sure it's at the right voltage and flowing smoothly and safely. These hubs are working 24 hours a day, 7 days a week to manage the incredible power that fuels our modern world. They are the unsung heroes of our electrical system, quietly doing their job to keep everything running just the way it should be for all of us. Imagine your family car. To make sure it runs well and is safe to drive, your parents take it to a mechanic for regular checkups. The mechanic checks the engine, the brakes, and the tires to find any small problems before they become big, dangerous ones. Apparatus testing in a substation is exactly like that, but for the electrical equipment. The word apparatus is just a fancy term for all the machines and devices inside the substation. Testing is the process where skilled technicians and engineers give each piece of equipment a thorough health check to make sure it's working perfectly and is ready to do its important job. This testing is incredibly important because the equipment in a substation works very hard. It's constantly managing huge amounts of electrical energy, and it operates in all kinds of weather, from scorching summer heat to freezing winter storms. Over time, parts can wear out, connections can become loose, or insulation can break down. Just like a tiny crack in a car's tire can lead to a flat, a small issue in a piece of substation equipment can lead to a big problem, like a power outage that affects thousands of people. Regular testing helps us find and fix these tiny issues early on. Apparatus testing is all about being proactive rather than reactive. Instead of waiting for something to break and cause a blackout, engineers use special tools to look inside the equipment and measure how well it's performing. They are like detectives looking for clues that might signal a future problem. These tests can tell them if the oil inside a transformer is still clean, if a switch can open and close fast enough, or if the insulation is strong enough to prevent electricity from escaping. By catching these things early, they can schedule repairs at a convenient time, preventing unexpected failures and keeping the power flowing reliably. Ultimately, apparatus testing is a promise of safety and reliability. It ensures that the substation can handle its job of managing our electricity without any surprises. It's a critical part of maintaining our entire power grid. When the equipment is healthy and working correctly, the substation can safely manage voltage, protect the grid from faults, and keep delivering the power we need for our daily lives. These checkups are essential for keeping our electrical systems strong, stable, and ready to power our communities day in and day out, ensuring our world stays bright and connected. Inside a substation, there are several key pieces of equipment that get the most attention during apparatus testing. The biggest and often most important are the power transformers. You can think of a transformer as the main voltage changer. It's a huge metal box, often filled with special oil to keep it cool, that takes the super high voltage electricity from the main power lines and steps it down to a lower voltage. Testers will take samples of that oil to see if it's still clean and effective. They also run electrical tests to make sure the internal wires, called windings, are in perfect condition and that the transformer isn't losing any energy. Another star of the show is the circuit breaker. A circuit breaker in a substation is like a giant, super-fast safety switch. Its job is to protect the grid. If something goes wrong, like a lightning strike or a fallen tree on a power line, the circuit breaker instantly trips and stops the flow of electricity to prevent damage to other equipment. During testing, engineers will measure how fast the breaker can open and close. It has to happen in the blink of an eye. They also check the mechanisms that operate it and ensure its internal parts are clean and ready to act at a moment's notice to keep the grid safe. Of course, we also have to test the switches. While circuit breakers are for emergencies, switches are used for routine operations, like redirecting power or isolating a piece of equipment for maintenance. They are like the light switches in your home, but on a much, much bigger scale. Technicians will test these switches to make sure their metal contacts are clean and make a solid connection when they are closed. A poor connection can cause the switch to get very hot and waste energy, so ensuring they work smoothly is very important for the substation's overall health and efficiency. They need to open and close reliably every time. Finally, there is a whole system of protective relays. These are the brains of the substation's safety system. Relays are smart devices that are constantly monitoring the flow of electricity. They are programmed to detect problems, like too much current, and they are the ones that tell the circuit breaker to trip. Testing these relays is extremely important. Engineers use special equipment to simulate a problem, sending a signal to the relay to make sure it sees the fault and sends the command to the circuit breaker at the correct time. It's like a fire drill for the substation's safety system. Working in a substation is a job that requires extreme caution and a focus on safety at all times. The amount of electricity flowing through the equipment is incredibly powerful and dangerous. Because of this, safety is the #1 priority during any apparatus testing. Before any work begins, the team holds a detailed safety meeting to discuss every step of the plan. They identify all the potential hazards and make sure everyone on the team knows their specific role. They follow a strict set of rules and procedures designed to keep everyone safe from the high voltages present all around them. One of the most important safety steps is called de-energizing. This means the equipment that is going to be tested is completely disconnected from the power grid. You would never try to fix a toaster while it's still plugged in, and the same idea applies here, but on a massive scale. Technicians use switches to isolate the apparatus, and then they apply safety grounds. These are special cables that connect the equipment to the earth, ensuring that no stray or unexpected electricity can flow through it and cause a shock. This creates a safe work zone where the team can connect their testing instruments without risk. The technicians themselves also wear special protective gear, known as personal protective equipment, or PPE. This includes things like hard hats, safety glasses, and flame-resistant clothing that can protect them from an electrical flash. They also use insulated tools and gloves that are designed to stop electricity from passing through them. Every piece of equipment, from the testing devices to the safety gear, is inspected before use to make sure it is in perfect condition. There is no room for error when you are working with so much power, so every precaution is taken very seriously. By performing these tests safely and regularly, the technicians and engineers are doing more than just maintaining equipment. They are ensuring that the entire power grid remains stable and reliable for all of us. Each successful test is another guarantee that the substation can handle storms, surges, and the daily demands we place on it. This careful, behind-the-scenes work prevents widespread blackouts and keeps electricity flowing safely to our homes, hospitals, and schools. So, the next time you flip a switch and the light comes on, you can thank the dedicated crews who work safely to test our substations and keep our world powered.